Okay students, so in last class we have discussed about your simple microscope and we have derived the expression for the magnifying power when the final image was formed at least distance of distinct vision. Now in today's class we will derive the magnifying power when the final image is formed at infinity. Now why do we consider the image formed at infinity? When we see an image at near point, it causes some strain in the eye. Often the object, in our case AB, is placed at the focus so that the final image is formed at infinity. Now, if the final image is formed at infinity, the parallel rays enters our eyes, as shown in the figure. The image formed at infinity will be more suitable and comfortable for viewing by a relaxed eye. Fine. Now next, let's understand magnifying power. Magnifying power is defined as the ratio of the angle formed by the image when situated at the infinity at eye to the angles formed by the object at the eye when situated at least distance of distinct vision. Now, what does this mean? Let us consider our object AB, which is placed at the focus F. If the object is placed at the focus, the image is formed at the infinity. If the image is at infinity, so my image makes some angle, isn't it? This is the angle made by the image, which is beta. Now let us consider our object. This object AB is placed at the least distance of distinct vision from our eye. Now this object also makes some angle, and this angle is alpha. Clear? So magnifying power is the ratio of the angle formed by the image beta to the angle formed by the image alpha. Now my alpha and beta are very small angles, so I can say beta s tan beta and alpha s tan alpha. So m equals to tan beta by tan alpha. Fine. Now from your figure A, okay, in this case let us consider your triangle AOB, this triangle. In the figure A, let us consider the triangle AOB, this triangle. Here there is an angle beta and it is an right angle triangle. So tan beta is the opposite side, h. H is the height of the object divided by the f. F is the focal length. So I can say tan beta equals to h by f. Similarly, from our figure B, if AB is my object of height h, which is placed at a least distance of distinct vision, this forms a right angle triangle. So tan alpha will be the ratio of the opposite side, which is h, divided by your adjacent side, which is d. So I can say tan alpha equals to h by d. And we know magnifying power equals tan beta by tan alpha. So I can divide this ratio, m equals to h by f divided by h by d. So let's simplify. H and h gets cancelled and this d will go to the numerator and f to the denominator. So I will have m equals to d by f. So this is the expression for the magnifying power when the final image is formed at infinity. Now, if you know the magnification for the image when it is formed at least distance of distinct vision was m equals to 1 plus d by f. So what difference do you see? In our case, this magnification is 1 less than the magnification formed at the near point. But which one will be more comfortable? This one will be more comfortable when the final image will be formed at least distance of distinction. Fine. Next, for your homework, you can take this question. A thin convex lens of focal length 5 cm is used as a simple microscope by a person with a normal near point 25 cm. What is the magnifying power of the microscope? Fine. Now in this question, they have given the focal length f equals to how much? 5 cm. And they have given you the normal near point of the human eye, that is your capital D, which is your least distance of distinct vision, which is how much? 25 cm. Fine. Now you have to find out the magnifying power. What you can do is, you can use the relation m equals to 1 plus d by f, where d is the near point and how much is this one? 25 cm, and f is the focal length, which is 5 cm. Okay. So in cases where they don't tell you where the final image is formed, you will always consider the final image will be formed at least distance of distinct vision. But if they have said that the final image is formed at infinity, you will use this relation. Clear? Now in our case, they haven't mentioned where the final image is formed. Therefore, I have to use which relation? This one, m equals to 1 plus d by f. Clear? So you find out the answer and submit it to me on WhatsApp. So that's it for today's class. Thank you.